Okay, hello everybody, this is question 5 of the kinematics one-dimensional problem. This is an example of projectile motion, vertical projectile motion in one dimension. It was taken from the, I think 2012 matric paper yes, I think 2012 in South Africa, the NSC paper. Okay, so it's quite a lot to read here. So let's begin. A ball is projected vertically upwards at 8 meters per second from the roof of a building which is 60 meters high. After 4 seconds, it hits the balcony. The ball is then bounced off of the balcony and lands on the ground. Okay, so let's just draw that at least. That will probably be a good idea. So let me draw it. Of course, I'm not using a ruler, even though there's a ruler there. I should probably use the ruler, but anyway. So let's just draw the building. Okay, put some windows here. Maybe make one of them cracked. Okay, so here's the ball. It gets projected upward with some initial velocity. It goes up, it reaches a maximum height, and then it proceeds to fall down. Eventually, it hits the balcony over here. And then it bounces up again, reaches some height, and then it lands on the ground. So let's just draw the ground there. Okay. We know this height is 60 meters, it was given to us. And what else was given to us? Let's see. Okay, the initial velocity was 8 meters per second. So let me just write that here is equal to 8 meters per second. And the other information we're given is that after 4 seconds, it takes 4 seconds before it hits the balcony. Okay, so that's some nice information. So let's see what if we can start answering questions. So question A, is the ball's acceleration at its maximum height 0, upward or downward? So we need to reason this out here. As soon as the ball is projected upwards, gravity starts acting on it. But something caused it to be projected upwards, so it was maybe thrown or kicked. So there was some force that was causing it to accelerate upward. When it reaches the maximum, we can call this y max. At y max, its velocity is 0, and then only gravity, acceleration due to gravity, then causes it to go down. So I would say at its maximum height, ball's acceleration is strictly downward. So we can do that. It's a one-word answer. Question A, downward. For reasoning, you can just write what I had explained. Okay, let's look at question B. Calculate the magnitude of the velocity at which the ball strikes the balcony. Okay, so we want final velocity. So we know final velocity is equal to initial velocity plus acceleration times time. Now the acceleration here is g, because it's due to gravity, which is negative 9.8 meters per second. So Vf is equal to Vi, which is 8 meters per second, plus negative 9.8 meters per second, and the time it takes is 4 seconds. So we'll see the second to the 1 there, times that makes it seconds to the minus 1, so we have units of velocity. So this would be 8 minus, now what is 4 times 9.8? 4 times 9.8 is 39.2. 39.2, I'll just say meters per second outside the brackets there, which is negative 31.2 meters per second. So this is a reasonable answer. It makes sense because the ball is falling downwards. So when it reaches over here, it's down at the velocity of negative 31.2 meters per second. Okay, then it bounces up, so let's see. Okay, the next question is C, calculate the height, h, of the balcony. Okay, so let me put h on the diagram. Okay, h, now we want to calculate h. So how are we going to do this? Well, what we can do is we can make use of this equation here. Let me just find some space there. C. So we're dealing with these 2 points. We're dealing at the top of the building and the top of the balcony. So we can call this y, let's call it y building, and let's call this y balcony. Instead of just calling it initial and final, sometimes you lose track. Final and initial only make sense within a context. So we can say, well, the final velocity squared is equal to the initial velocity squared. So I suppose again with consistency, maybe I should say the velocity on the balcony and then for initial put velocity on the building. Because like I said, final and initial can just cause confusion sometimes. So let's do it like that. So the velocity on the building squared is equal to the velocity, of the balcony is equal to the, I'm gonna have to do this part again. Okay, so like we label it there with the y building and y balcony, let's do the same with the velocities. So the velocity on the top of the building, okay, no, this is wrong as well. So like I said, instead of using final and initial, let's use building and balcony. So in this context, the velocity when it reaches the balcony, so let's call it velocity balcony squared is equal to the velocity of the building squared plus twice the acceleration times the distance that it's traveled. So the distance was y building minus y balcony. So basically what we're saying here is, what is the velocity when it hit from the building, from the top of the building, all the way to the top of the balcony. This is the distance that matters, and the acceleration, of course, is due to gravity. Now, I suppose what we want to actually calculate here is this value over there. So let's make that the subject of the formula. So we have Yeah, so let's just make it the subject of the formula. So we make it the subject of the formula. We have, let me say, it implies y building minus y balcony is equal to, so we take this over and divide through by 2a, so we have v squared balcony minus v squared building all over 2a. We can plug these values in, so we know that the velocity when it hit the balcony we calculated in previous problem, it's negative 31.2 meters per second all squared minus, and then the velocity of the building was the original, which was 8 meters per second all squared all over 2 times negative 9.8 meters per second. And if we plug this into the calculator, what do we get? Well, 31 squared minus 8 squared is equal to some number. Now we must just be careful because we're going to get negative. So this is positive, this is positive, but it's divided by a negative number, so we're going to get negative 46.4 meters. Now what this means is that the balcony just lives 46.4 meters below the top of the building. So if I were to write this in words, is the balcony, or I can say the balcony's position is 46.4 meters below the top of the building. So then what would h be? So I mean, if we have our building and we know this is 60 meters and this is 46.4, we just do a little arithmetic to get h. So h is equal to 60 minus 46.4 meters. And this, if I'm not mistaken, is 13.6 meters. So this is the height of the balcony. This is how far away the balcony is from the ground. And I think that answers the question. Yes, that is correct. So question D now actually requires us to sketch a velocity time graph. So it's quite a bit to read here. So it tells us the ball bounces off the balcony with velocity 27.13 meters per second and strikes the ground 6 seconds after leaving the balcony. So let me write that, or at least draw it on the diagram. So it goes up again. So this V was when it hit the balcony coming downward. This V going upward now is going to be 27.13 meters per second. And then it travels and it comes down and it takes 6 seconds. Okay, we want the velocity time graph, so I think we're gonna have to make another page here. Or maybe not. Okay, let's see. D. So this velocity time graph is gonna have positives and negatives. So let that be velocity. let's make 0 here maybe. This is time. So this is time measured in seconds, velocity measured in meters per second. So we know this thing started at 8. The initial velocity was 8 meters per second. So if we go back to the drawing here, the ball was projected upwards with 8 meters per second. It then reached the maximum height. At maximum height, velocity is 0. Velocity then becomes negative all the way after 4 seconds until it gets to negative 31.2. So at time 0, which is the initial time, the velocity was 8 meters per second. The velocity then goes down to 0 at maximum height, and then it continues down at 4 seconds. At 4 seconds, it is negative 31.2. This is when it hits the balcony. Then it bounces upward with 27.13 meters per second. So there's the discontinuity in this graph, because it went now from a negative value here immediately to a positive value. Let me just make it a little bit higher, which is 27. Just going to write it there, 27.13. It then travels again downward. We don't really care where it goes to, but it travels, takes 6 seconds. And then after 6 seconds, let me just do this. I mean, it probably will bounce again, but that information is irrelevant. This is that 6 seconds that's mentioned after bouncing off the balcony. So here you have basically 2 straight lines, 2 parallel straight lines. Let's see if we've identified everything we needed to from the problem. What did the problem want? The initial velocity to which the ball was projected, that is there. It's 8. Time it takes the ball to strike the balcony, yes, we've got it. We can put it here if we want to. Strikes balcony. Never be shy to just add additional information, make it easier for the marker. And so that's there. So initial, I can just put the initial VI. We can even put the maximum height, maybe. And then the other one is, let's see what else they want. The velocity which the ball bounces off the balcony, we can say this is here. This piece here bounces off the balcony. And then what else do we want to see there? The time when the ball strikes the ground. Well, they did tell us it takes 6 seconds, so this is the time. So I mean, that has been specified. And of course, like I said, we don't need to specify the speed at which it hits the ground. It wasn't asked. So that covers everything for this problem. It was a bit long, but hope you understood what's happening. Alright, thanks guys. Bye bye.